Thank you very much. I prepared a slide in order to be shorter, as short as possible. So, okay, it is not the last version, but I would like to thank also to colleagues who are not able to attend this meeting, but send their contributions. These also will be included in the volume of this conference I'm planning to do. First is a paper published just 2 months ago, Shanta and Garbai, Investigation of the Dynamic Equilibrium of Atmospheric CO2 Concentrations. The lifetime is close to 4 years, according to their mathematical derivation. Willy Soon also had a contribution here. It is practically a list of their papers in Ceres Science. It is very interesting. The title is Science of Climate Change, Comparing and Contrasting the Roles of Atmospheric CO2 and the Sun. And Nicolas Caffetta also sent an extended abstract to me, and his papers was published last year. Valentina Zharkova also, when he knew about this conference, at once he sent me 2 messages. Global warming issue, the second is Grand Solar Minimum and Little Ice Age. And I would like to say special thanks, of course, to the key lecturers also, but to Javier Vinos, whose book, Solving the Climate Puzzle, will be published in Hungarian language. Maybe next year, we expect. The translation is ready into Hungarian, but we does not have any publisher yet in Hungary. And to Professor Embei Istin, I would like to tell that remind him that consensus building is out of the scientific methods, I think. If everybody would be agree with each other, there would not be any original idea in science. It would mean the end of the science. So, thank you, Mr. Chairman.
Thank you very much. Professor Putsayabes, it's your turn.
I kept some notes. First, Mr. Chairman, I would like to make a small comment about your question, about the role of the vertical gradient. I believe it is very important that actually what I showed is that if there is no gradient in the atmosphere, which actually is the tendency of the atmosphere to maximize entropy, should be isothermal, without gradient, then the action of the radiative actively gases would be 0. Exactly. So it's important when the gradient, the vertical gradient, is increasing, then also the temperature is increasing in the in the surface. So now we have 6.5 degrees. This is nothing, of course, there are some reasons, but this is not a constant. This changes through time. And there has not been given attention to this fact, but I believe it is very important. Another comment I would like to make is about evaporation and the energy consumption. I combined these 2 presentations, which show that water is very important in climate. I'm happy to listen to the presentation about the importance of evaporation, and of course the comment why the temperature increases faster in land than in sea. Of course, this is a very nice observation, and evaporation is one issue, but it's also another issue is the thermal capacity. of the water, which is the biggest of all common substances. And that's why the water is the climatic thermostat in Earth. Of course, this is very important. I mean, it is crazy, in my view, because I am a hydrologist, it is crazy that we give so much focus and projection and promotion of CO2, while water is the real agent behind the changes in climate. Just to give you a number and perhaps give another view about the importance of the energy produced by human combustion of fossil fuels. Because there were, in the last presentation, there were some calculations. I have done such calculations, and we have, let's say, metaphorically, we have the human locomotive, which we showed in the photos, the human locomotive, and then we have the natural locomotive, which is the evaporation and the water cycle. The calculations that I have made show that we can fully neglect the human part, because the proportion is 1 for human, 2,100 for the natural locomotive. So this is I think I made correctly the calculations. So then there is a question whether the skeptics provide reliable explanations or not. I don't think they are unable to provide. Actually, everybody who writes a paper has to provide some explanations, even though the explanation is not the only thing, the only goal of a scientific let's say, paper or research or whatever. Because there are things that we cannot explain, but we can deal with. In engineering, for instance, we always have this problem. We don't explain, but we kept records, and we are able to design projects, to design works without having an explanation. So this is not necessarily the ultimate goal, to have an explanation, because the explanation could be also wrong. For instance, the explanation that CO2 increase produces temperature increase because of several mechanisms that are known to everybody, etc., is wrong, in my opinion. And I think I have proved that it is wrong. Correlation is mentioned, but correlation is not necessarily identical to causation. It can reflect causation, but it could be the other way. And how do we know that it is the other way? We measure the time lag. Whichever occurs first, this is the cause. It cannot be the other way. This is a very elementary necessary condition. Okay. And then I come to the last point, I think, which is the question. Pardon? Yeah? The big question, as it was put by the colleague, what prevents reaching consensus? It was characterized as the big question. And I'll give you an answer and also make another question. First, the question, how much money has been allocated to those supporting dissenting ideas? And how much money was given to those presenting the orthodox, the mainstream idea, researching the mainstream ideas? Okay. I presented my papers. I showed a list of 13 papers, and the money the EU, for instance, has given me zero. Just one of the papers had a small funding because it was not related to climate, but to the design of flood works in Greece, and it was Greek money. Only one, and not related to climate, so zero. So the question is, okay, 95% or 99% or 100% of scientists agree with the orthodox theory. What does it mean? Somebody says 95%, 97% of scientists agree with whoever funds them. Okay, I believe I have to commend the Academy, even though it is a minority. I understood from what the chairman said in his initial talk. Only one person has this view of climate, so he is a minority, but this is the correct thing to do if you are science. And what prevents people from being, for not achieving consensus? The answer is simple. There are still people who are scientists. That prevents from reaching consensus. Because still, even though they get zero money, they want to be scientists. And this is a very simple answer, because in science, disagreement is necessary. Το αντίξουν συμφέρον εκ των διαφερόντων καλείς την αρμονίαν και πάντα κατέριν γίνεστε. This is Heraclitus, which means opposition unites. Το αντίξουν συμφέρον. From different things comes the finest harmony, and everything is created by strife. That's Heraclitus 2006 years ago. And I will stop with Aristotle. Φίλος μεν Σοκράτης, φιλτάτη η αλήθεια. Socrates is dear friend. Dearest is the truth. Thank you.
Three things I would like to say. I had a very good friend in Belgium, Hungarian, István Marko. He was one of the best professors of chemistry in the Université Catholique de Louvain. And he was giving a class in the first year for all students about what we discussed today, but about climate change. But he was a skeptic about the impact of mankind on, and he had a lot of difficulties in the university. But he was such a bright chemist, bright scientist. He worked with 2 Nobel Prizes. And there is a chemical reaction with his name, the reaction of Marko, that he didn't care about the opposition. There was a petition against him, again at the university. And we copied the petition not to lose it. And then when he was introducing demand to get financing, he was introducing CO2 and climate change. And one opposition asked him, why are you introducing CO2 in your studies? He said, I'm obliged, otherwise I will get no financing. So this is the sad reality. If you don't introduce CO2 in your research program, you don't get financing. This is normal science. Second thing, the first chapter of my last book, I'm talking about the filioque. Do you remember the filioque? Ah, you, Greek, Orthodox, you know that. During the first millennium, mankind in Europe was fighting to know if the Holy Spirit is coming from God the Father or from God the Father and the Son. And it took centuries of discussion, until the Emperor Charles in the 9th century, year 800, say, stop, I will decide what it is. And he decided what it is. It's not yet finished after 2,000 years. Huh? Climate change is finishing in the same situation. We will not get an answer because it's too complicated. First of all, science is extremely complicated, and nobody knows what it is exactly. And we have to admit that we should be modest and not believe that 100% of people believe the same thing. That's not true. And therefore, we should be pragmatic. And the pragmatic, I think, is what I try to convey. Are we stupid enough to stop our world, our prosperity, leave Chinese to prosper just because we are fighting among us about the role of CO2? I don't think that the world will accept to destroy our economy, our welfare on such difficult issue. Third thing, thank you very much for your last presentation. It's the first time that I hear somebody saying the first part of your presentation. The first part of your presentation is the position of my chemistry professor. You see that I'm quite old, so you imagine the age of my chemistry professor, Professor Georges Gooskens. He was the main professor of chemistry in Bristol University, and he's saying the same thing of you for the first part. But for the second part, I'm a little bit more prudent about what you say with pyrolysis. When you make pyrolysis, the carboxylic links break down, and so you produce CO2. You always produce CO2 in pyrolysis. And when you have carbon after the pyrolysis, if you burn it, it will end up in CO2. So I'm a little bit prudent on that. Thank you very much.
Thank you very much, Professor Furfari. And at the very end, you may allow me to summarize my personal view on this subject, which I received several impact on that in this conference as well. First, is climate changing? Yes, it is. Second, I still believe that the basic reason for that is the increased carbon dioxide emission. Do we want to reduce carbon dioxide emission? No, because of two reasons. First, our resources, energy resources, are of 87% of fossil origin. Second, we do not want to reduce material consumption. And what may be the solution? I say resilience. I heard this word somewhere among the speakers. Resilience would mean smart and gradual adaptation to the situation, reduction of the fossil energy consumption, forestation, insulation, and material recycling, and patience. Not like the deep green fraction in the European Parliament. Thank you very much again for this very interesting conference, and I must stress again that it was not the official standpoint of the Hungarian Academy of Sciences. We had heard a lot of individual opinions, several of them could be grouped together in order to bring scientific discussion further. And I think we are a bit more informed now than we have been 3 or 4 hours ago. Thank you very much for your attention.